Good afternoon, everyone. Welcome to another WifiGear webinar with me, Chris King. I hope it's nice and warm wherever you are today. It's certainly pretty hot down here in sunny Dorset. This afternoon, we're going to be talking all about Tachyon Networks and their 60 gigahertz offering. At WifiGear, we've been working with Tachyon now for 2 years coming up, and it really has been a fantastic success for us. We've seen significant growth over those 2 years. They're by far and away our biggest growing point-to-point manufacturer in our range. I can quite honestly say we're selling more Tachyon than Ciclu these days, more Tachyon than Cambium these days, more Tachyon than Ubiquiti 60 gig point-to-point these days. Not that there isn't a place in the market for those products, but just go to show the growth and the suitability of Tachyon for the UK market. We've seen really good growth in the security industry with our security subdisties, with the interference-free solutions that they can offer CCTV backhaul. We're seeing some fantastic inroads into the WISP market, and I think that's only going to grow as we've got new products on the horizon, like the little 303L, which we're going to learn more about shortly. Why is it doing so well for us? I think a few things. I think the functionality of their products are really, really good. I think the price point is really appealing. And the other thing we get fed back from a lot of our customers is the guys at Tachyon are really accessible and really helpful. And you don't really get that with the big manufacturers. The face of that, the person that most of our customers are talking to and talking about when we mention the face of Tachyon is Hal, CEO of Tachyon, who joins us today from the States. Morning, Hal. I think you're on mute there, buddy. How are you doing? You all right?
Yeah, doing well, doing well.
Thank you for joining us early. How early is it for you over there at the moment?
It's so early. It's like 10 a.m.
Oh, it's not too bad. I thought it was earlier than that. So you've had your Cocoa Pops and you're ready to go.
It's all right. 8 cups of coffee. We're ready.
Brilliant. Thank you. Right, a little bit of housekeeping. Please feel free to ask questions as we go. Use the Q&A on the top of your screen. It really is better if we've got some questions and it's not just Hal and I talking for the next sort of 30 to 45 minutes. Pop them in the Q&A box as we go, and I'll do my best to find the right moment to interject Hal and discuss the questions as we go along. And then we'll catch up with any other bits at the end. Feel free to be as technical as you want, product related, company related. The whole point of having their product designer on the call is so that we can answer those interesting and technical questions. Any examples you want to talk through, all that type of thing, pop it in the Q&A box and we'll do our best to answer it as we go. Right, I'm going to pass over to Hal now, who's going to run through a bit of a company introduction, bit of 60 gig chat, and then we're going to look at some new products that they've got coming out and what else they've got on the roadmap.
All right, let me see. First, make sure that popped up okay.
Yeah, we're looking good.
All right. Yeah, thanks everyone for joining today. I'm excited to share kind of a quick recap of where we are as far as products go on the Tachyon lineup. Answer any questions about that, as well as give a good intro to the new TNA 303L 65 that Chris mentioned. And again, thanks to WifiGear and Chris and team for allowing us to come on today and share all of these great updates. So let's dive in. I just want to do a quick recap. Most of you probably are all already aware of all of this, but I wanted to go through this again because it's really important, I think, to understand and remember that this millimeter wave 60 gigahertz band really represents a huge amount of real estate in terms of spectrum when it comes to what's available in the UK and in fact in most of the world. There's a couple of interesting things about the 60 gigahertz. One, as you see here, it does represent around 90% of the unlicensed spectrum available. It does not have any of the annoyances of some of the other bands, such as DFS or radar avoidance. So you don't have to worry about a warship popping up but doing some war games out on the coast and taking out half the network, right? I've heard that's may have happened before. And then as far as like other bands like 6 gigahertz, it has AFC or spectrum coordination databases required. If that database goes down, you may have some challenges on that. Not an issue currently in the UK because 6 gigahertz is not open for outdoor use. But yeah, it's if it did become available, it's another thing you don't have to deal with in the 60 gigahertz band. the newest, the original products that were shipping in the 60 gigahertz band were really centered around a particular range of that band that's absorbed by oxygen. Um, that has since changed, and there's a 14 gigahertz of spectrum. You still have that middle hump that's absorbed a lot by oxygen, which has its place in the toolbox as well, because it's sort of a self-cleaning zone. But then you also now have picked up quite a bit of spectrum that's outside of that spectrum range. And it's going to behave more like a licensed E-band link when it comes to, atmospheric attenuation. This band is millimeter wave. It means that it will be affected by rainfall, and it's not how much or how frequently it rains, I should mention. It's really about the intensity of the rain. And again, all of this you can model and understand availabilities and those kinds of things, and we'll talk about that a bit later. So all of this to say, you don't have to worry as much about things like interference, DFS, AFC, all those kinds of things in this band. It's very friendly for use. Now, so let's compare a little bit between various different technologies. So of course, with fiber, you get lots of capacity and low latency, highly secure, and not a lot of interference on a fiber. However, time to market can be a challenge, and then cost is very painful. So typical cost, it's quite a wide range, but that's typically done in terms of cost per home passed, not necessarily cost per home connected. And so that's another interesting way to compare wireless and fiber, which is passing homes with wireless is very cost effective. Passing homes with fiber, less so. And then you only really have to pay for customers on wireless that you actually need to connect or devices that you need to connect. With fiber, it's quite the opposite. You have to get to wherever you need to go and pass whatever you need to pass, and that cost is there, right? Um, all the other technologies such as sub 7 gigahertz unlicensed. So this is another area. Again, you're going to get the same benefits that you do with 60, meaning that you can throw up access points quickly. So you have a quick time to market. You have a low cost per subscriber. But as many as of you probably know, interference is intense. It's not a lot of spectrum. There's nothing to really stop a lot of those signals from interfering. It's difficult to do frequency coordinations. So you end up with limited capacity and potentially a lot of noise. Um, and then comparing to 5G LEO satellite, again, you're back into high cost, slow time to market. You need to get licensed spectrum. In the case of satellites, you need to deal with your infrastructure entering the atmosphere and burning up every few years. So there's always that. So yeah, so if you look at overall the whole picture, what we are striving to bring to market is the best of all of these worlds. You're going to end up with multi-gigabit capacity, low latency, very secure. We're using narrow beams. It's difficult to intercept, and it's encrypted if you do. And then you still get the benefits of the fast time to market and the low cost per subscriber. So it's really the best of all of these worlds. So let's talk a little bit about the first products that we launched in this lineup. So the first products were actually the TNA 301 and 302, and these were pure beamforming products. And what that means is that there's still a narrow beam, but we're able to steer that beam around, up, down, left, right, and do that automatically on a per transmission basis, whether it's point to point or point to multi-point. And what that does is it allows you to avoid some of the challenges of alignment. So if you were coming from 5 gigahertz band or uh, hopefully not, but the 2.4 gigahertz band and those lower bands, you really didn't have to deal with painful aiming. Maybe if you got up to a 2 meter dish or something crazy, you start to get into pretty small beams, and that would require a lot of patience, a lot of time doing the alignment. But for the most part, 5 gigahertz is put up an access point, point it in the rough direction, put up a client, point it in the rough direction, and those are going to be able to find each other because those beams are relatively wide in the lower spectrum. When you get up into 60 gigahertz, we make up the distance by doing higher gain beams. Again, early products in this were very focused beams. And in general, if you want to go further, you have to continue to focus that beam. The trade-off there is that it can be more difficult to do the alignment. So we considered the 301 and the 302 sort of let's call it a halfway house. It got you into the 60 gigahertz bands, into moderate distances. And those are still very relevant today when you're doing campus and say links up to about a kilometer. These fit very well, but you still get the benefits of the self alignment. And if you can get it in the rough direction, it does all of that rest of that alignment for you. And so this is really the great product to transition into 60 because it's going to feel more like a 5 gigahertz product versus going straight to a pencil beam or sort of a laser beam kind of product in this band. So the 301 and the 302, they look very much the same on the outside. The differences are going to be the antenna module that you can't see, that it is behind that plastic radome. The 301 is going to be a wider azimuth coverage, 120 degrees by 45 vertical. The default mode is going to be access point. And then both of these products are going to have a 2.5 gigabit multi-gig Ethernet port that's backwards compatible to 1 gig, 100 meg, all of the old standards. And then there's a secondary 1 gigabit port that's available to do power over Ethernet out to power other things like cameras, a secondary radio for a repeater or something like that. 302 is going to have the same physical ports on it. Again, very similar. The difference is going to be the scanning range. It's a higher gain beam, and the scanning range is reduced to 45 by 45 roughly. Again, very easy to get that for doing installations. As long as you're within that 45-degree beam pattern, it's going to be able to finish that alignment for you and link up fine. The default mode on that one is going to be client mode. Out of the box, a 301 and the 302 will link together with their default configurations. Of course, we do recommend that you change some of that, like the passkey and those kinds of things. But at least it's a quick and easy, benchtop test to get started and get them linked up.
I think they, sorry to interject there, Hal, I think these two have been a really great introduction to 60 gigahertz for us, particularly perhaps some of the security installer guys, the CCTV guys who aren't massively into wireless, or they've just been used to 5 gigahertz. They had reservations around 60 gigahertz, isn't it? Is it hard to align? Is it more complicated? Can I do it? And actually, one each of these, as you say, one's in access point, one's in client mode. They're auto beamforming. They'll do vast majority of it for you. And this is kind of like 60 gig for beginners, isn't it?
It is, yeah, and 60 gigahertz for we'll call it the easy button for those cases where you don't need to go more than a kilometer, for example.
Yeah.
And I will mention too, the beamforming is real time. It's not something that just happens during installation and then it figures out the best thing and then sits there. This is actually in real time, packet by packet. And so if you're we've had people do installations onto boats in a marina, for example. And this is able to compensate for that movement in real time. So you don't need to worry about poles swaying in the wind and those kinds of things.
Is that, without sounding really cheesy and really salesy, Hal, is that something all brands offer, or is that something unique to Tachyon?
Yeah, so other people that are doing real-time beamforming would have those same advantages. But compared to something like a fixed beam or a high gain, you're not going to get those kinds of benefits and have to worry about things that are moving.
Perfect.
Of course, after we launched the 301 and the 302, the natural next question was, how do we go further? Everyone always wants to go further, faster, as usual. And so we came up with a novel idea to release a radio which could be a modular type radio, and you could actually mate it with different antenna kits to get different beam patterns and different gains. And so what was launched out of that was our 303X. As a standalone bare radio, it's also going to be beamforming just like the first two that we talked about. The beam pattern is a little bit different. The antenna beam is a little bit lower. It's optimized for these antenna kits. So it's not going to be quite as strong when it's in standalone naked mode, let's call it. But yeah, once you dress it up, it's going to do wonders. Default mode on this one is going to be client as well. I just want to reiterate, every one of our products today, they can be access point or client or point to point. So it's really just a software change. We don't do any kind of licensing keys or any of those kinds of annoying things where you bought a product, you think you have all the features, and you find out later, no, you need to have a little bit of extortion in your life, right? So we don't do any of that stuff. What you get the full product with all of the features unlocked. And again, on the 303X, you're going to have the same two physical Ethernet port interfaces, one 2.5 gig port with PoE in, and then a 1 gigabit port with PoE out that can be turned on and off in software. These all support the full band. The channels 1, 2, and 3 are going to be the channels that are going to be highest absorption by oxygen. They're great for high density interference, or any kind of interference is going to be cleaned up by oxygen for you. And then it leaves channels 4, 5, and 6 basically for longer distances out of that range. So this particular model can be mounted both as you see it as it is here with the Ethernet ports pointed down. It can also be mounted rotated 90 degrees. This is an IP67 product, so it's watertight. If you mount it rotated, you're going to be in a different polarization and essentially end up with another set of channels that you can use. So, for example, a lot of people use rotated for point-to-point to feed, if they're feeding maybe a point-to-multipoint setup that's all on vertical. And we do support 802.3 AT standards-based PoE, so this can go into a PoE switch. We also support passive PoE. They come with that PoE injector in the box with your massive UK power cord and ready to go. So no extra PoE to purchase there. As I mentioned, this is a modular system, and so we've also released a set of different antenna kits that can be mounted to the front. If I go back for a second, you'll notice there's 4 ears on that radio in the corners. That's used to attach it to the various antenna kits here. So these, the first 3 that you see here are for very directional, either point-to-point or as a highly directional client radio. And they go up as they go up in gain from 33 dBi up to 42. The beam steering is reduced, the beam gets more focused, and then the ease of alignment is reduced as well because of that. We do provide on our website a downloadable step file for an aiming tube. I've heard if you ask nicely, Chris will also print them out for you as well. Super nice guy.
Yep, consider it done.
And yeah, that aiming tube, essentially, once you attach it to the back of the radio during the installation, you put the other side in the aiming tube. It's should link up. That usually gets it close enough, and then you do fine tuning on the alignment to get it optimized. And then take off that aiming tube, move it to the next stop, and repeat. And then the last 2 are going to be a little bit of a different kit there. So those are going to be preserve the azimuth scanning. And the point is to reach that antenna gain of 30 dBi, which allows in ETSI rules to unlock higher EIRP overall. So without a 30 dBi antenna, you're limited to about 40 dBm EIRP. Once you can hit that 30 dBi antenna minimum, you're able to unlock up to 55. I do believe, and maybe Chris, you can comment on this, that does once you go above 40, you do need to do some kind of registration in the UK for links.
Yep, that was going to be my next line. So everything, or the 3 radios we saw before this slide, if you're using them naked, as Hal calls it, without any antenna kits on the front, you don't need a license. It's within the regs. You can pop them up and away you go. The moment you put one of these antenna kits on the radios, you go above the threshold for needing a light license in the UK, which is, I believe, is £75 for 5 years, and that's for as many links as you want. So it's purely a case of going on to Ofcom, registering once as somebody that installs them, and then you're good for 5 years to get installing as many as you want. There's no increase for as many links as you install or anything like that.
Excellent. All right. I mentioned that we have this secondary Ethernet port. So as you extend these distances, you need to worry more and more about rainfall. And we have some test results, I think, that'll really illustrate this. We're very proactive. You'll find we have a link calculator online where you can put in link parameters and it'll spit out not only receive signal levels, those kinds of things. It also tells you, it'll give you an estimate on how much rainfall it can handle from an intensity basis in either millimeters per hour or inches per hour if you're on the imperialist system. And then, yeah, so as you extend those ranges out, rainfall does become a bigger impact. And so it's possible if the rain gets strong enough, you will lose that link and be without traffic being able to flow across the link. To accommodate this, we allow a backup path to be set up on the secondary Ethernet ports. We're technology agnostic when it comes to that. It could be as simple as an Ethernet cable if you have an Ethernet cable run between the two sites. Typically, this is used with some kind of a low frequency backup radio operating in 5 gigahertz, typically in the UK. But it could be something else too. It could fail over to LTE for all we care. It's essentially configurable in the web UI on the client side. You're going to set a threshold that if the signal level drops below that threshold, it'll switch to the backup path in the radio. And then once that signal level is back above that threshold for a user specified amount of time, it'll switch back. That specified amount of time is there just to prevent flapping. So if it's kind of on the border, it won't sit there and every other second switch back and forth. You can tell it, look, wait 30 seconds, wait 300 seconds, whatever, that we're above this RSL signal minimum, and then switch back. That kind of prevents that kind of flapping happening. In our lab, typically this failover happens. The failover happens immediately. Usually takes the network about a second to kind of catch up with what's happened. Things like ARC tables to update and those sorts of things. But yeah, this allows you to, if maybe you're configuring your link to be 3 nines, 4 nines availability, and you just want to basically be able to drop back to reduced capacity during these heavy rain events, and then switch back to full capacity once those have passed. And so, as I mentioned, we do have power over Ethernet out. Couple of caveats there. The power out is the same as the power in this case, typically 48 volts. If you are trying to connect something that's like a 24-volt radio, you'll need to use some kind of a voltage converter. Those are on the market. That'll take something like 48-volt PoE and convert it to 24-volt passive PoE if you're needing something like that. And I think, Chris, you also maybe have some options for those lower frequency backup radios, I understand.
Certainly do, yep.
Excellent. I will say though, depending on where you are, again, this comes down to rain intensity. So this is an example link that one of our customers did in Czech Republic. You can see it had been up for active for 10 months, and it actually had not dropped at all during those 10 months. It just hadn't hit that sort of higher intensity rain. In this case, we'll call it yellow or above, or maybe slightly above yellow on like a radar. In this case, we're getting about a minus 48 signal level. You can see there it's almost 4.2 kilometers in this point to point and passing about 1.7 gigabits per second. This is on channel 6. And it looks like they had passed a little over, almost six terabytes, a little over 6 terabytes of traffic since this had been installed. So a good example here showing that, again, it's about rain intensity. You need those reds on the radar in order to make this link drop.
I think that's a really valid point, and it's something we get asked a lot, is when people are just learning about 60 gigahertz or looking at different options away from 5 gigahertz, should we say. People talk about 60 gigahertz, they talk about rain. They think the UK is a really rainy place and that can't be a good thing. But actually, as Hal's alluded to there, it's not how often it rains, it's how hard it rains. We don't actually get that much tropical rain here in the UK. And I think our experience so far has been, unless you're pushing really long distances, unless you're pushing probably 2 or 3 kilometers plus, the rain doesn't come into it massively. It's only really when you're doing those longer distances that you probably got to be a bit more aware of rain fade. Use the link calculator to see how much room for error you got, how much rain that link can withstand before it might potentially drop.
That's right. Well
I've got a question for you, Hal, that's just popped in.
Sure.
Ramuna says, can the links be bonded at 2+0?
So we don't support bonding today, so it's strictly used as a backup path. That could change in the future. If we had an integrated radio that we could control, but not knowing what's plugged in there, it's really hard to do any kind of bonding.
Okay, makes sense.
Thanks for the question, then. So yeah, those were the products that have been launched and shipping now. As a group, I think we're close to a couple 100,000 radios shipped. So quite a few of those out there. But yeah, the next question was, now that we've gone super far and we have high capacity access points and those kinds of things, what do we do in the case where we really need an affordable link? We only need to go a super slow 1 gigabit per second. And so we introduced the 303L65 as the first product. This one, as Chris is showing, it's quite compact, smaller even than Chris's head, as you can see. And he has not an unusually sized head either. So there you go, even better compared to the phone. So this is as hinted in the name there, we do have a 65 millimeter RF lens in the front there. That's why it looks a little bit funny on the front, and that's focusing that beam while giving us still some beam steerability. It does support the full band like the other products, channels 1 through 6. It can be installed in either H pole or V pole. It does only have a single 1 gigabit per second Ethernet port, and so that's going to limit your speeds, as you can see in the speedtest.net speed test, to that 950-ish each way. There's a little bit of overhead on the Ethernet protocol that keeps that from showing 1,000. But that's as close as you can get without going over. It does have the integrated antenna, brings it up almost to the maximum limit in the UK. It's right around 54 dBm EIRP, so quite optimized there. We do have a secondary port, which I think you could see when Chris held that up. So there's an Ethernet port, and then there's a USB 2 port. The USB 2 port was added for ease of installation. So we'll be adding a list of compatible Wi-Fi dongles, but the idea here is that you can plug in a USB Wi-Fi dongle during the installation. It's going to create a local hotspot, Wi-Fi hotspot. You can connect to that with your phone, tablet, whatever you're using for the installation. You don't need to drag a laptop up, but you'll be able to connect that wirelessly to it, do the configuration, do the alignment, look at signal levels, all kinds of fun things like that. Then when you're done, pop it out, put the plug back on, and move on to the next one. So it's really just about convenience of installation without adding cost. For those of you interested, the Wi-Fi dongle that we support should be pretty much anything based on the MediaTek MT76 chipset family. But again, we'll post in a knowledge base article on our website various supported dongles. I think we have a few models in the lab. I think we bought those on Amazon for maybe $25. So they're very affordable, little small dongle that you can plug in. And this is the most affordable full band client point to point on the market today, and can easily give you gigabit connections with it. Just a couple of ideas on how far you can go and what we would say are the maximum connection distances. Again, these aren't going to include things like rainfall, so you'll need to back this off a little bit to include rain. But this kind of gives you a good idea. So going 301 to 303L, so that's going to be like a 90 to 120 degree sector with the 301. To a client that's the 303L, you're looking at about 1.5 kilometers. If you go from a 302 to a 303L, because the 302 has a little bit higher gain antenna, you'll end up with basically a 45 degree sector or so, but you're going to be able to bump that distance up to about 1.8 kilometers max. Going to our modular system with the 303X and the S90 antenna kit, you're going to bump that up even further to 2.5 kilometers. And then for a very compact, super small, but still gigabit point to point, going to two 303L65s, you're looking at about a 3 kilometer distance there. It'll probably even link a bit further. Here's some real world testing that we did. So this first one is using that 302 AP that we were talking about before. This was done at about 1.35 kilometers. You can see we're at full speed there on MCS 99, and we actually beat the estimated signal target. We got a minus 59 on this one instead of an estimated minus 63. And I just wanted to show this. This is an actual web UI on the radio itself. And I mentioned we really like to highlight. We're not trying to hide anything as far as what the impact of rain and those kinds of things can do. you'll notice in the bottom left corner, it actually tells you, says at the lowest modulation, this link can withstand a heavy rain of 18 millimeters per hour or a max path loss. That translates to about 8 dB per kilometer that it can handle. So we're very active. This would be a very red color on the radar and quite a heavy rain. And this was at 1.35 kilometers in this particular test. Speed test there showing that it's running full speed faster than you can go on the Ethernet port. So this is a wireless speed test. A couple of other cases here on this same 1.35 kilometer test range. So this is going to be a point-to-point. So this is using a pair of 303Ls. You see that signal level has bumped up now to minus 54 on channel 5. What's interesting, though, is that even on channel 3, which is the channel that has the highest level of oxygen absorption, we were still able to link fine at 1.35 kilometers, and we're still getting over a gigabit per second on our wireless speed test. And this is going to be, in this case, MCS 66. We're at a minus 67. So you will notice, though, that it's only going to handle a light rain on channel 3 of 3 millimeters per hour. So if you're in the Middle East, maybe this is still a great link. If you're in the UK, would recommend using one of those upper channels to get a little bit more signal budget there. But it's nice to know that you have all of these options, even in these high oxygen absorption range. So that basically covers the 303L, and so we'd love to open it up to questions on the band, on the technology, on the products, anything that comes to mind. Happy to answer any questions on these items.
Perfect. There's one question already in the chat waiting for you, Hal. Is cloud management of the links coming?
Yeah, so let's talk a little bit about management and kind of the history there. So management today, obviously, there's the web UI. We do support syslog and remote syslog. We also support SNMP for monitoring, V2C and V3, as well as we have a private MIB that you can load up. A lot of our customers are using things like Zabbix and those kinds of things to do the monitoring. We also have a full RESTful API that's available, and that's available at no extra charge. And you're able to interact with that API as much as you want directly with the radio. You can do things like change the configuration, do bulk firmware upgrades, as well as do monitoring as well. And we have on our Git have posted code examples, for example, on how to do a bulk firmware upgrade using the API. All of that, that with a little bit of ChatGPT help, you could probably do your own thing. We did do a prototype cloud management as maybe about a year ago. It was fine. It actually used the same RESTful API to handle those things. What I'll say is that the feedback was yet another NMS that's bespoke. And then a lot of people didn't seem to care for the cloud management part either. Difficult for us on our side to control cost on that. Maybe oversharing a bit here, but our plan then is to pivot, probably release some sort of an open source on-premise option. That's been worked on a bit. And then after a couple of higher priority has been getting these product launches out. That's our core. But yeah, you can expect a bit later to see an option from more like an on-premise versus cloud management. If you're very interested in cloud management, please reach out to us. We can probably work with you to get something set up for you to host yourself based on the prototype that we did before.
Perfect. Thank you, Hal. Next question in the chat. Do you have local support in the UK-EU? UK, you've got WifiGear as first line support. We're more than happy to help. We do help customers on a regular basis, both our customers and our sub-distributor customers. As far as the EU is concerned, Hal?
Yeah. So happy to share a bit on that. So Tachyon has two locations. One is in the US. We're a US-based headquartered company. And then our other office is going to be in Lithuania. And that's actually where we do all of our radio production as well. So all of our devices are made in EU in Lithuania in our facility there. And then we also have obviously local people there too. So yeah, we cover at least a good array of time zones, and very good array of time zones for the UK market.
And free support is available via the support pages on your website. People can register for free, log a ticket. The Tachyon guys will get back to them.
That's right. Exactly.
Perfect. Any more questions, guys? Whether that's product based for Hal, anything about for WifiGear or UK supply stocks, things like that, pop them in the chat. Do let us know. That's what we're here for. If not, we will wrap it on up for you. That's been really informative, Hal. Thank you.
My
Here we
pleasure.
go.
Thank you guys for having us. Yeah.
There's one more. Ramirez likes his questions. Can 60 gigahertz links be used in moving objects? Now,
so it is.
Now I'm going to show my technical knowledge here.
Yes.
The packet, the auto alignment after every packet that you discussed means it can, within reason. So I know we've done a project with a customer where it was on a floating. I'm trying to think what they're called now, like a marina. The floating platforms, there's a proper name for them. There was a CCTV camera on there. It was moving, obviously with tides and waves, and because of the realignment after every packet, pontoon, thanks Rick, the link was fine. The link stayed up and worked fine because of that realignment after every packet.
And I would say even if you wanted to put it on a vehicle, the trick would be that you need to keep line of sight on the beamforming. But it would work even if you're driving down the road, maybe 30 miles per hour. It would still work. Again, it's in real time doing beamforming and beam steering.
So an example we've done with 5 gigahertz radios before has been lift shafts, where people have wanted like CCTV cameras in a lift shaft, and the lift has gone up and down. We've put an AP at the top station on the top of the lift. We could do that, could we?
Yes, absolutely.
Marvelous. Okay. Any more questions in the chat quickly before we let Hal get back to his breakfast over in the States? Cool. Well, thank you very much for your time, Hal. If anybody's got any more questions, feel free to drop me an email, get in touch with us at WifiGear. You can get in touch with the Tachyon team via their website. We're all here to help. We're happy to help you plan links, spec projects, all that kind of thing. If you want to get yourself some NFR kit, we'll do you some NFR pricing or some bundles. If you haven't used Tachyon yet and you want a first time try, just reach out to us or one of our subdisties in the UK, and we'll happily look after you. But thank you very much for joining us. I hope you found that useful and informative, and I'll catch up with you soon. Thank you very much.
Thanks, everyone.